Hey guys, it's Mr. Haverick. Sorry I can't be with you guys to do 8.5, but these are the notes on solving rational equations and inequalities. Now, to solve a rational equation, you have to clear any denominators by multiplying each term on both sides of the equation by the least common denominator. What do we mean by that? Well, let's look at this example. We have this equation right here, x plus 12 over x equals 7. All right, so there is a denominator. Easy enough, it's x. So I have to multiply every single thing by x. So the point of doing that is to get rid of the x in the denominator. But remember, if I multiply this by x, I've got to multiply my leading term by x. I have to multiply the other side of the equation by x. Just everything. Multiply everything by least common denominator, whatever it happens to be. So then we get this. We get x squared plus 12 equals 7x. This is a quadratic. So when we have a quadratic equation, we set them equal to 0, like they did here, factor it, and then we solve. And then it's very important that you always check your solutions. Because if we go back up to the original equation, we have an x in the denominator. So x really cannot equal 0, because that would make the entire equation undefined. So here we get 3, we get 4, they both work. Sometimes they both will work, sometimes only one will work. Sometimes neither of them will work, but you'll get the idea as we go along. Here we have this, x over 2 plus 1 equals 4 over x. So I have two denominators, 2 and x. So my least common denominator is 2x. So I'm going to multiply every single thing by 2x. What happens here? The 2's cancel. What happens here? I get 2x. What happens here? The x's cancel. So I get x squared plus 2x equals 8. So I'm going to set that equal to 0. And then I'm going to factor it. What are the factors of negative 8 that add up to 2? Well, that would be 4 and negative 2. So I'm going to get x plus 4 and x minus 2 equals 0. So we get x equals negative 4 or 2. But I still have to go back and check. All right, so if I put negative 4 in there, negative 4 divided by 2 is negative 2. 4 divided by negative 4 is negative 1. Negative 2 plus 1 is negative 1. All right, so the negative 4 checks. 2, put 2 in there. 2 divided by 2 is 1, plus 1 is 2. 4 divided by 2 is 2. 2 checks. So they both work. So both those answers are correct. Number 2, there seems to be a typo. This should be x. Here, this has got to be an x. So wherever you're doing your work, make that an x. Now I'm going to change colors here. So the only denominator is x. So I'm going to multiply every single thing by x. What happens here? X squared. What happens in the middle? X's cancel out. So I just get minus 6. And what does that equal? That equals x. I'm going to set it equal to 0 by subtracting x from each side. So I get x squared minus x minus 6 equals 0. Factor it. That is going to be x minus 3 and x plus 2. Trust me on this one, it is. Remember, I told you after you've done enough of these, you'll be able to do them in your head. So we get x equals 3 or negative 2. And again, you got to go back and plug them in. If I got 3 here, let's see, that would be 3 minus 6 divided by 3, that's 3 minus 2, that's 1. That works. Negative 2. Negative 2 minus 6 divided by negative 2, that would be negative 3. Minus negative 3, that'd be negative 2 plus 3, that'd be 1. So they both work. So 3 works, 2 works. All right, number 3. Let's do another color, just for fun. I love doing more than one color. All right, so least common denominator here is going to be, well, there's only one. It's going to be x. So I'm going to have x times x. I'm going to have 4 times x. And I'm going to have plus 5 over x times x. So that gives me x squared equals 4x plus 5. These guys are going to cancel. So I'm going to move both of those over to the other side. I always want to keep my leading term positive if possible. It just makes it easier to factor. So I'm going to move these to the left, set it equal to 0. Factors a negative 5 that add up to negative 4. Well, that would be negative 5 and positive 1. That equals 0. So x equals 5, x equals negative 1. So go back and double check. Plug in 5. 5 over 5 is 1. 4 plus 1 is 5. That works. Negative 1. 4 minus 5 equals, yeah, that works too. So they both work. So that is where we're at. Now, sometimes, like I said, you're going to get what we call an extraneous solution. This is a solution where it is not a solution that is not a solution. I love that. Solution that is not a solution. Basically, it's anything that makes it false. So sometimes that's going to happen, unfortunately, with these guys. It just does. So let's take a look at this example here. We got 4 plus x divided by x minus 6 plus x divided by 2 equals 10 divided by x minus 6. So the least common denominator is put them together, 2 and x minus 6. Now, here's the deal. We got to remember, x cannot equal 6 because that would give us division by 0. So, let's see. We multiply everything by 2 times x minus 6. So in this first term, the x minus 6's cancel. In the second one, the 2's cancel. In the third one, the x minus 6's cancel. So we get 2 times x plus 4 minus, or plus x times x minus 6 equals 2 times 10. Work it all out, combine like terms, and we get this guy here. X squared minus 4x minus 12 equals 0. When I factor that, I get x plus 2, x minus 6. All right, so x equals 2 or x equals 6. Now, we go back and check. Here's the problem. Just like I said at the top, I can't have x equals 6 because that would give us division by 0. So this guy here is an extraneous solution. So the only solution that's going to work is x equals negative 2. So let's work out a couple of these so you can see what we're talking about. We have 1 over x plus 2 plus x plus 1 over x plus 2 equals x over 5. So least common denominator. We're looking at 2 things here. First of all, least common denominator is going to be 5 times x plus 2. Also, let's recall x cannot equal negative 2 because that would make division by 0. So I'm going to multiply by 5 x plus 2. I'm going to take x plus 1 over x plus 2, multiply that by 5, x plus 2, and it equals x over 5 times 5 x plus 2. Okay. X plus 2's cancel out on both of these guys. So I just get 5 here. I get 5 times x plus 1. This one, the 5's cancel. So over here, I get x times x plus 2. Distribute. 5 plus 5x plus 5 equals x squared plus 2x. Going to move everything around, set it equal to 0. I'm actually going to do this. I'm going to move these guys over here because I want to keep this positive. So I'm going to say 0 equals x squared minus 3x minus 10. 5 plus 5 is 10, and that's that. So now when I factor this, it's going to be x minus 5 and x plus 2 equals 0. So, run out of room, but we're going to get x equals 5 or x equals negative 2. Well, this one here is not going to work because we already said x cannot equal negative 2. We'll do one more real quick before my tablet dies. The least common denominator here is 3 times x minus 1, and x cannot equal 1. So I'm going to multiply out here. This will be x over 3 times 3 x minus 1 plus x plus 3 over x minus 1 times 3 x minus 1, and that's going to equal 4 times 3 x minus 1 over x minus 1. So the 3's cancel here. I get x squared minus x. The x minus 1's cancel here. I get 3x plus 9. And the x minus 1's cancel over here. I get 12. So if we put everything together, I get x squared plus 2x. If I subtract 12, I get minus 3 equals 0. So that factors to x plus 3 and x minus 1 equals 0. So x equals negative 3 or x equals 1. But we already said x cannot equal 1, so this guy is extraneous. I did include an extra page here for you guys to kind of help you out figuring out least common denominators and how to figure out these extraneous solutions. Look that over. Look over the examples in the textbook. They're also very good. And also in the textbook, you're going to see they talk about what happens with inequalities. And I'm going to charge up my tablet. Maybe I'll throw up another video about inequalities. But for now, this should get you going on the assignment, and we'll talk about it when I get back. All right? Good luck. Email me if you got questions.